So from the previous lecture till now in this video, we learned how you can access and write 1 or 0 to single bit of a register available in our microcontroller. That is to all the bits available in our port 1, P0, P1, P2, P3, P4, P5, P6 and P7. We just return 1 or 0 to all the separate bits. But now we are just going to learn another method, that is using this SFR type. We are just going to write 1 byte of data to this SFR. That is, instead of writing 8 bits of data separately to individual bits of the register, you can write 1 byte of data in a single line to this port 1. That is nothing but to this address 0x90. So the 8 bits of data starting from 0x90 will be stored till 0x97. That is to all these separate bits. You can see from this first sequence, you are not only writing 1 to this bit 0, but also you are writing 0 to all the other bits available in your register. So instead of writing all the 8 bits and giving a separate value for all the bits, you can provide 8 bits of data or 1 byte of data directly to the starting address 0x90, which is nothing but port 1. So I am just going to use this port 1 defined in the type SFR for writing 1 byte of data instead of writing 8 bits of data separately defined using S bit. So now assume that this is the port 1 of our microcontroller. These 4 bits are LSBs and these 4 bits are MSBs, and initially they are having the value 00. And this is the table for converting data from binary to hexadecimal, which we are going to use for converting this register value into hexadecimal for loading the data to the register. So you can see in the register the bit order goes like this always. The one on the right, the bit that is available on the extreme right is the 0th bit of the register, that is P1.0, and 1.1, 1.2, 1.3, 1.4, 1.5, 1.6 and here is 1.7. So all the registers, if you take, the order will be in this format. The numbering comes from right to left. So let's take the first sequence. We are making the port 1 pin 0 as 1 and all the other bits as 0. So I am just going to write the value 1 to P1.0 and I am going to leave 0 for all the other bits. So here next step is, I just want to convert this 8-bit binary data into hexadecimal before loading that to the register. So split this 8-bit of data into two 4 bits, that is LSB and MSB. Let's take the LSB. So LSB is 0001 in binary, which is nothing but 1 in hexadecimal. So I am writing 1 over here. And the MSB is nothing but 0000, which is nothing but 0 in hexadecimal. So the value that we get in hexadecimal for this 00000001 is 01, which will turn on the P1.0 and it will make all the other bits starting from P1.1 to P1.7 low. So the equivalent value for this binary data in hexadecimal is 01. So I am just going to write this 01 to the port 1. So I am just deleting these 8 lines and instead of that I am just going to write port 1 equal to 01. So if you are writing a hexadecimal byte of data to any register in your microcontroller, you just want to add this 0x in the beginning, which is indicating that you are writing a hexadecimal data to that particular register. So nextly you can see the second sequence where we are turning on the bit 1 and we are turning off all the other bits. So now I am making the bit 1 low and I am turning on the pin 1.1. Now you can see the MSB is 0000 and the 0 is remaining over here, and the LSB is 0010, which is nothing but 2 in hexadecimal. So I am changing this as 2. So the value is 0x02. So instead of this, I am just going to write port 1 equal to 0x02. And now let's take the third sequence where I am just making the pin 1.2 as high and all the other bits as 0. Now I am making 1.2 as high and all the other bits as low. Now also the MSB is 0, so 0 remains here, and here 0100 is nothing but 4 in hexadecimal. So I am changing this 2 to 4. So the value here is 0x04. 0x04. Now the next sequence is we are turning on the 1.3 and all the other bits low. Now I am making this as 1, this is nothing but 1.3, and I am making this as 0. Now you can see the value of this LSB is 8 over here. So I am changing this as 8. So the value in hexadecimal is 08. 0x08. And the next sequence is we are turning on the 1.4 and rest all off. So 1.4 is this one. So now you can see the LSB is 0, 0000, and the MSB is 0001, which is nothing but 1. So now the value becomes 10, which is nothing but 0x10. So this will turn on the bit 4 and all the other pins off. And the next step is we will turn on the pin 1.5 and all the other pins off. Now you can see the MSB value is 0010, which is nothing but 2. So I am changing this to 2 and the LSB remains 0. So now I am just making this port 1 to be 0x20. And the next sequence is I am making the P1.6 high and all the other bits low. 1. Now you can see the value of this MSB 0100 is nothing but 4 and the LSB remains 0. Port 1 equal to 0x40. And the final sequence is nothing but we are turning on the 7th bit and turning off all the other bits. So we are turning on this bit and we are turning off all the other bits. So this 1000 in binary is nothing but 8 in hexadecimal. So the value that we get for this sequence is 80. It's 80. So you can see our program has been simplified much better. That is, we are writing a single byte of data for every sequence to the port 1. Now I am compiling the sketch. You can see the compilation is done with 0 errors and 0 warnings. Open this Proteus simulation software and again load the program. And now again when I run the program, you can see the same output. So in this manner you can write 1 byte of data to all the addresses that are defined using the type SFR, or you can write 1 byte of data to all the registers defined using the type SFR in your microcontroller. You can see this is the development board that I am going to use for demonstrating all the outputs that I get in my hardware. And here in my development board you can see the ISP pinouts where you can connect the USB ASP programmer pinouts directly to this connector for programming this microcontroller or for uploading the hex file directly to this microcontroller. So the programmer that I'm going to use is USB ASP programmer, and I'm going to connect the pinouts of this programmer to my ISP programming lines available in my development board like this. And I'm going to connect this USB ASP programmer to my PC through USB cable like this. And the other end of my USB ASP programmer, I'm just going to connect that to the PC through USB cable. You can see the terminal connections of ISP programmer is this one. Reset is connected to reset pin of the ISP programmer, and clock is connected to clock, MISO to MISO, MOSI to MOSI, and VCC ground to the respective pins. So you can see all the pins are directly provided in my development board, or if you are not having a development board, you can also build the circuit in a breadboard for uploading the hex to your microcontroller like this. So this is the pinout of this USB ASP programmer. I just want to connect the MOSI to the pin 6 and MISO to pin 7 and clock to pin 8, as well as the reset pin must be also connected to the pin 9. Then the VCC must be connected to the pin 40 and ground must be connected to pin 20. In addition to this, you just want to provide a 11.0592 MHz crystal to this 18th and 19th pin of the microcontroller, and then you just want to pull this EA pin high so that you are indicating to the microcontroller that you are just going to use the internal ROM of the microcontroller. So using this circuit, you can also upload the hex file to this microcontroller even in breadboard. After the connection is done, open the program ISP software. The link for the software is provided in the description of this video. You can directly download it from there. Now you can see in this software, this program ISP icon is not highlighted. That means the programmer is not yet connected. Before that, you just want to choose the microcontroller that you are working on. So our microcontroller is AT89S52 that is being selected, but regardless of all the microcontrollers available, you just want to select the microcontroller that you are working on. So I am choosing AT89S52, and then now when I connect my USB ASP programmer USB cable to my PC, you can see this icon is highlighted, which means that the programmer is connected to the PC USB port. Now for uploading the flash or the hex file to this software, you just want to click on this file tab and click on load flash and go to the respective project folder where you have stored the project files, and there you can find the hex file inside this objects folder, and click on this hex file and click on open. Now you just want to check the required operations that needs to be done when you click on this auto button. So I need the microcontroller to be erased as well as program the flash to the microcontroller, and then after programming I want the flash to be verified. So these three are the operations that I need, so I am just leaving these three checked. Other than that, I am not checking any other checkbox. And remember one thing, that while programming, the power from the USB ASP programmer is sufficient for the microcontroller. So you need not connect any external 5V signal to the microcontroller for powering up. Now for uploading the hex file, just click on this auto button. Now you can see the hex file is being downloaded to your microcontroller AT89S52. And the programming has been done. Now build the circuit to see the output in the hardware. So this is the development board that I'm going to use in my hardware, and this one is the port 1. You can see this is port 1.0 and this 8th pin is port 1.7, and these are the 8 LEDs available in my development board. So these are the anodes of each of these LEDs. This is the anode of this LED and second one is the anode of this LEDs, and it goes on like this. I'm just going to connect all these 8 pins of port 1 to each of these anodes of the LEDs. I'm just going to use this jumper cables. So all the connections has been completed, and regarding the cathodes of these LEDs, cathodes will be internally grounded in this development board, so we need not worry about that. Now that the circuit connections is over as per the schematic shown to you, I'm just going to power up this development board with the help of 12 volt 1 amps adapter using this power jack connector available in my development board. And after connecting, when I turn on the power supply, you can see the 8 LEDs that is connected to wholly the port 1 is toggling as per the logic written in our program. So this is the output that I got in my hardware. See you in the next lecture. Thanks for watching.